Hello students, welcome to this lecture on statistics. In this lecture, we will cover miscellaneous exercise question number 1 to 6. So let's get started. This is disclaimer. So we will solve NCERT miscellaneous exercise question number 1 to 6. So look at question 1. So the question is the mean and variance of 8 observations are 9 and 9.25 respectively. If 6 of the observations are 6, 7, 10, 12, 12 and 13, then find the remaining 2 observations. So first of all, try it yourself and then see solution. So here we will solve this question step by step. First, let's assign variables to the unknowns. So we will let the remaining 2 observations be x and y. So this helps us set up the equations to solve for these unknown values. So the complete set of observations is 6, 7, 10, 12, 12, 13, x and y. So it's important to list all the data points including the unknowns x and y, so we can use them in our calculations for mean and variance. So recall the formula for the mean. The mean, often written as x bar, is the sum of all the observations divided by the number of observations. Simply, mean x bar equal to sum of xi divided by n. Here n is the total number of observations, which is here 8. Now let's substitute our values into the mean formula. So we have mean 6 plus 7 plus 10 plus 12 plus 12 plus 13 plus x plus y is divided by 8. Okay, and it is given to us mean of 8 observations is 9. Okay, so mean 6 plus 7 plus 10 plus 12 plus 12 plus 13 plus x plus y divided by 8 is simply 9. So this equation will help us to find x and y, these two unknown values. Now let's simplify the equation. So adding up the known numbers, so we get 6 plus 7 plus 10 plus 12 plus 12 plus 13 equals 60. So the equation becomes 60 plus x plus y divided by 8 is equal to 9. Okay, now multiplying both sides by 8 gives us 60 plus x plus y equal to 72. Okay, so note this equation. Now subtracting 60 from both sides, so we find x plus y is equal to 12. So this is your first equation. Next, let's recall the formula for variance. Okay, so variance sigma squared equal to 1 divided by n of summation from I equal to 1 to n of xi minus x by whole squared. Since it is given that variance is 9.25, so we can write 9.25 is equal to 1 divided by 8 sum of xi minus 9 whole squared. Okay, therefore 9.25 equal to 1 divided by n summation from I equal to 1 to 8 of xi minus x bar whole squared, where x bar is 9 and our data points are 6, 7, 10, 12, 12, 13 and x and y. So we will use these values in our variance equation to solve for x and y. So first, let's write the formula for variance using the data we have. So the variance is 9.25 equal to 1 divided by 8 times minus 3 whole square plus minus 2 whole square plus 1 square plus 3 square plus 3 square plus 4 square plus x square plus y square minus 2 times 9 times x plus y plus 2 times 9 whole square. So let's substitute the values and simplify the equation. So we calculate each squared difference. 9, 4, 1, 9, 9, 16. And so the equation becomes 9.25 equal to 1 divided by 8 times 9 plus 4 plus 1 plus 9 plus 9 plus 16 plus x square plus y square minus 18 times x plus y plus 162. So the equation is now 9.25 equal to 1 divided by 8 times 48 plus x square plus y square minus 216 plus 162, since x plus y is 12. Now let's further simplify the equation. So 9.25 equals to 1 divided by 8 times x square plus y square minus 6. To isolate x square plus y square, we multiply both sides by 8. That gives us 9.25 multiplied by 8 is equal to x square plus y square minus 6. So 74 equal to x square plus y square minus 6, and adding 6 to both sides, we get x square plus y square is 80. Remember, earlier we found that x plus y is 12. So let's use this equation along with x square plus y square equal to 80 to find the values of x and y. So we will use the identity for the square of a sum next. So let's square both sides of x plus y equal to 12. That gives x square plus y square plus 2xy is equal to 144. So this equation will help us to relate x square plus y square and x times y. Now let's use both equations together. So we have x square plus y square equal to 80 and x square plus y square plus 2xy equal to 144. So by comparing these, we can solve for 2 times xy. So subtracting x square plus y square is equal to 80 from x square plus y square plus 2xy equal to 144. So we get x square plus y square minus 2xy equal to 80 minus 64 is equal to 16. And it implies x square plus y square minus 2xy is equal to 16. Now let's rewrite the equation as x minus y whole squared equal to 16. Now taking the square root of both sides, so we get x minus y equal to plus or minus 4. So the difference between the two unknowns numbers is either 4 or minus 4. So we have x plus y is 12 from earlier calculation. So now with x minus y equal to plus minus 4, we have two equations to solve for x and y. So let's solve these two equations together. X plus y equal to 12 and x minus y equal to plus minus 4. So we obtain x equal to 8 and y equal to 4 when x minus y equal to 4. And x equal to 4 and y equal to 8 when x minus y equal to minus 4. Thus the remaining observations are 4 and 8. So this completes our solution. I hope this question is clear to all of you and every step are clear to all of you and you are getting my point. So now let's move to the next question. In this question, we have the mean and variance of 7 observations are 8 and 16 respectively. If 5 of the observations are given to us, 2, 4, 10, 12, and 14. Then we have to find the remaining two observations. So how can we solve this question? First of all, think about this and try it yourself and then see the solution. So let's solve this question step by step. So first of all, let the remaining two observations be x and y. So our full list of observations are 2, 4, 10, 12, 14, x and y. So recall the formula for the mean. Mean written as x bar. So mean x bar is equal to summation xi divided by n. So now let's substitute our values into the mean formula. So we get mean equal to 2 plus 4 plus 10 plus 12 plus 14 plus x plus y divided by 7 equal to 8. So 8 we have given mean of 7 observations is 8. Okay. So this equation will help us relate x and y to the known values. Now let's solve for x plus y. So multiplying both sides by 7 gives us 56 equal to 42 plus x plus y. Now subtracting 42 from both sides, we find x plus y equal to 14. Next, let's use the variance formula. So variance is given as 16 in this question, and formula is sigma squared equal to 1 divided by n times summation from I equal to 1 to 7 of xi minus x bar whole squared. So the equation becomes 16 equal to 1 divided by 7 times minus 6 whole squared plus minus 4 whole squared plus 2 squared plus 4 square plus 6 square plus x square plus y square minus 2 times 8 times x plus y plus 2 times 8 square. Okay. Now let's substitute what we know into the variance formula. The variance is 16. So we write 16 equal to 1 divided by 7 times 36 plus 16 plus 4 plus 16 plus 36 plus x square plus y square minus 16 times 14 plus 2 times 64. And since x plus y is 14 here, next let's simplify inside the brackets. So adding up the squares gives us 108. So the equation becomes 16 equal to 1 divided by 7 times 108 plus x square plus y square minus 224 plus 128. Now let's combine the numbers inside the brackets further. So it will give us 16 equal to 1 divided by 7 times 12 plus x square plus y square. Now to isolate x square plus y square, so multiply both sides by 7 to get 112 equal to 12 plus x square plus y square. Then subtract 12 from both sides to get x square plus y square equal to 100. So we found that x square plus y square is 100. Now let's use the fact that x plus y is 14. So if we square both sides of this equation, then we obtain x square plus y square plus 2xy equal to 196. Here x square plus y square is the sum of the square and 2xy is the twice the product of two unknown numbers. So from x square plus y square is equal to 100 and x square plus y square plus 2xy equal to 196, we will obtain 2xy equal to 196 minus 100. And it implies 2xy equal to 96. Now subtracting 2xy equal to 96 from x square plus y square equal to 100. So we obtain x square plus y square minus 2xy is equal to 100 minus 96. And it implies x minus y whole squared equal to 4. Taking the square root of both sides, we find x minus y equal to plus minus 2. Therefore, from x plus y equal to 14 and x minus y equal to plus minus 2, we obtain x equal to 8 and y equal to 6 when x minus y is 2. Alternatively, if x minus y is minus 2, then x equal to 6 and y equal to 8. So the final answer, the remaining two observations are 6 and 8. So I hope this question is clear to all of you. So now let's move to the next question. Look at question number 3. The question asks us to find the new mean and new standard deviation of the resulting observations. And we have the mean and standard deviation of 6 observations are 8 and 4 respectively. And if each observation is multiplied by 3, then we have to find the new mean and new standard deviation of the resulting observation. First of all, try it yourself and then see solution. So students, let's try to solve this question step by step. First of all, let's start by naming our 6 observations. So we will call them x1, x2, x3, x4, x5 and x6. So it is given that mean is 8 and standard deviation is 4. Now remember the formula for mean. So the mean is calculated as the sum of all observations divided by the number of observations. That is x bar equal to summation of xi divided by n. So plugging in our values, so we have x bar equal to x1 plus x2 plus x3 plus x4 plus x5 plus x6 divided by 6 is equal to 8. Now let's see what happens if we multiply each observations by 3. So we will call the new observation as yi. Each yi is equal to 3 times the corresponding xi. So for each I from 1 to 6, we have yi equal to 3 times xi. That is xi equal to yi divided by 3. So the now new mean, which we will call y bar, is calculated as y1 plus y2 plus y3 plus y4 plus y5 plus y6 divided by 6. Now substituting the values, we get y bar equal to 3 times x1 plus x2 plus x3 plus x4 plus x5 plus x6 divided by 6. So new mean y bar is equal to 3 times x bar. It implies y bar is 24 since x bar is 8. Now standard deviation. So first try to recall the formula for standard deviation. So the standard deviation sigma is given by sigma equal to square root of 1 divided by n times summation from I equal to 1 to 6 of xi minus x bar whole square. So now let's substitute the known value for the standard deviation. Since sigma is 4, so we have 4 square equal to 1 divided by 6 sum from I equal to 1 to 6 of xi minus x bar whole squared. Now let's solve for the sum of the squares deviation. So multiplying both sides by 6, gives us sum of xi minus x bar whole squared from I equal to 1 to 6 equal to 96. So we have y equal to 3 times x bar. So we can also write x bar as 1 divided by 3 times y bar. Now let's substitute the values of xi and x bar in summation from I equal to 1 to 6 of xi minus x bar whole squared equal to 96. Then we obtain summation from I equal to 1 to 6 of 1/3 times yi minus 1/3 times y bar whole squared equal to 96. So now let's focus on the sum of squared deviations for the new set of observations. So we see the equation sum from I equal to 1 to 6 of yi minus y bar whole squared equal to 864. Since standard deviation of the new observations sigma 1 equal to square root of 1 divided by n times summation from I equal to 1 to 6 of yi minus y bar whole squared. So sigma 1 equal to square root of 1 divided by 6 times 864. This is equal to square root of 144 and this is 12. Hence the standard deviation of the new observations is 12. I hope this question is clear to all of you. And now let's move to the next question. Now look at question number 4. So in this question we have given that x bar is the mean and sigma squared is the variance of n observations. We call x1, x2 up to xn. Now prove that the mean and variance of the observations ax1, ax2 up to axn are a times x bar and a square times sigma squared respectively, where a does not equal to 0. So first of all, try it yourself, then see the solution. So let's solve this question step by step. First, let's clearly state what we are working with. So we have n observations. We call x1, x2 up to xn. The mean of these observations is x bar. The variance of these observations is sigma squared. Now let's write out the formula for variance explicitly. So sigma squared equal to 1 divided by n times summation from I equal to 1 to n of xi minus x bar whole squared. Now let's consider what happens if we multiply each observation by a constant a. So we define the new observations as yi equal to a times xi for each I. So yi equal to a times xi, which means xi equal to 1 divided by a times yi. Next, let's find the mean of the new observations. The mean of y is y bar equal to 1 divided by n summation from I equal to 1 to n of yi, and this is equal to 1 divided by n times summation from I equal to 1 to n of a times xi. So it is equal to a divided by n times summation from I equal to 1 to n xi, and since x bar is 1 divided by n of summation from I equal to 1 to n of xi, so this is simply equal to a times x bar. Therefore, mean of the observations ax1, ax2 up to axn is ax bar. Now let's substitute the values of xi equal to 1 divided by a times yi and x bar equal to 1 divided by a times y bar in this formula. Sigma squared equal to 1 divided by n of summation from I equal to 1 to n of xi minus x bar whole squared. So we will obtain sigma squared equal to 1 divided by n summation from I equal to 1 to n of 1 by a times yi minus 1 by a times y bar whole squared. It implies a square times sigma squared equal to 1 divided by n times summation from I equal to 1 to n of yi minus y bar whole squared. And this is variance of new observation. Thus, the variance of the observations ax1, ax2 up to axn is a square times sigma squared. I hope this question is clear to all of you. So now let's move to the next question. In this question, we have the mean and standard deviation of 20 observations are found to be 10 and 2 respectively. On rechecking, it was found that an observation 8 was incorrect. Now, calculate the incorrect mean and standard deviation in each of the following cases. If wrong item is omitted, second condition, if it is replaced by 12. Okay. So first of all, try it yourself and then see solution. So let's solve this question step by step. So first, let's start with the first case. What happens if the wrong item, which is 8, is simply omitted from the data set? So we have given number of observations n equal to 20. The incorrect mean is given as 10. So incorrect standard deviation is given as 2. Let's recall the formula for mean. The mean written as x bar is equal to the sum of all observations divided by the number of observations in symbols. That is x bar equal to 1 divided by n summation from I equal to 1 to 20 of xi. Now let's substitute the value we know into the mean formula. So we have 10 equal to 1 divided by 20 times summation from I equal to 1 to 20 of xi. Now multiplying both sides by 20, we get sum of xi from I equal to 1 to 20 is equal to 200. So the incorrect sum of observations is 200. So this sum includes the wrong value 8, which we will need to adjust in the next steps. So now let's correct the sum of all observations. So the sum of all observations is equal to 200. That is incorrect sum. Okay. So now correct sum of observations 200 minus 8. This is 192. So the correct mean is 192 divided by 19, which is 10.1. So the correct mean after omitting the wrong value is 10.1. Next, let's recall the formula for standard deviation. The formula is sigma equal to square root of 1 divided by n summation from I equal to 1 to n xi squared minus 1 divided by n squared times summation from I equal to 1 to n xi whole squared. So sigma equal to square root of 1 divided by n summation from I equal to 1 to n xi squared minus x bar whole squared. Since x bar is 1 divided n summation from I equal to 1 to n of xi. So it implies 2 equal to square root of 1 divided by 20 and correct sum from I equal to 1 to 20 of xi squared minus 10 whole square. It implies 4 equal to 1 by 20 times incorrect sum from I equal to 1 to 20 of xi square minus 100. It implies incorrect sum from I equal to 1 to 20 of xi squared equal to 2080. Therefore, correct sum from I equal to 1 to 19 xi squared equal to incorrect sum from I equal to 1 to 20 of xi squared minus 80 squared. It is equal to 2080 minus 64. This is equal to 2016. Therefore, correct standard deviation equal to square root of correct sum of xi squared divided by n minus correct mean whole square. This is equal to square root of 2016 divided by 19 minus 10.105 whole square. This is equal to square root of 106.105 minus 102.111. This is equal to square root of 3.994 equal to 1.998. Therefore, the correct standard deviation is 1.998. If the wrong item is replaced by 12, when 8 is replaced by 12, incorrect sum of observation is 200. Therefore, correct sum of observation is 200 minus 8 plus 12 equal to 204. Therefore, correct mean is correct sum divided by 20 is equal to 104 divided by 20 equal to 10.2. Therefore, correct mean is 10.2. Now, let's recall the formula for standard deviation. Sigma equal to square root of 1 divided by n times summation from I equal to 1 to n of xi squared minus 1 divided by n squared summation from I equal to 1 to n xi whole squared. This implies sigma is equal to square root of 1 divided by n summation from I equal to 1 to n xi squared minus x squared whole squared. It implies 2 equal to square root of 1 divided by 20 times incorrect sum from I equal to 1 to 20 of xi squared minus 10 whole square. It implies 4 equal to 1 divided by 20 times incorrect sum from I equal to 1 to 20 xi squared minus 100. It implies incorrect sum from I equal to 1 to 20 of xi squared equal to 2080. Therefore, correct sum from I equal to 1 to 20 xi squared equal to incorrect sum from I equal to 1 to 20 of xi squared minus 8 whole squared plus 12 squared. It is equal to 2080 minus 64 plus 144. This is equal to 2160. Therefore, correct standard deviation equal to square root of correct sum from I equal to 1 to 20 of xi squared divided by 20 minus correct mean whole squared. This is equal to square root of 2160 divided by 20 minus 10.2 whole squared. Now, correct standard deviation is square root of 108 minus 104.04. This is equal to square root of 3.96. This is equal to 1.98. Therefore, correct standard deviation is 1.98. I hope this question is clear to all of you. So now let's move to the next question. Look at question number 6. So in this question, we have the mean and standard deviation of a group of 100 observations were found to be 20 and 3 respectively. Latter one, it was found that 3 observations were incorrect, which were recorded as 21, 21 and 18. So find the mean and standard deviation if the incorrect observations are omitted. So first of all, try it yourself, then solve it, then see the solution. So let's solve this question step by step. So we have given the number of observations n equal to 100. So next, the mean of these 100 observations is given as 20. And now let's recall the formula for the mean. So we know that x bar equal to summation of xi divided by n. So we have given here mean x bar is 20. Okay, so it implies 20 equal to 1 divided by 100 summation from I equal to 1 to 100 of xi. It implies summation from I equal to 1 to 100 of xi equal to 20 times 100. This is equal to 2000. So the incorrect sum of observations is 2000. Now, given incorrect observations are 21, 21 and 18, and these has to be omitted. So the correct sum of observations is 2000 minus 21 minus 21 minus 18 equal to 2000 minus 60 equal to 1940. So correct mean is correct sum divided by 100 minus 3 equal to 1940 divided by 97. This is simply 20. Okay, so correct mean is 20. So correct mean is 20. Given incorrect standard deviation sigma equal to 3. So let's recall the formula for standard deviation. So sigma equal to square root of summation from I equal to 1 to n xi square divided by n minus summation from I equal to 1 to n of xi divided by n whole square. So let's write the formula to make it easier to work with. That is sigma squared equal to summation from I equal to 1 to n of xi square divided by n minus x bar whole square. And we have given sigma is 3 and n is 100. So let's substitute these values into the formula. So we have 3 square equal to summation xi square divided by 100 minus 20 whole square. So incorrect sum xi square equal to 100 times 9 plus 400. This is equal to 40,900. So correct sum from I equal to 1 to 97 of xi squared is incorrect sum from I equal to 1 to 100 xi squared minus 21 squared minus 21 squared minus 18 squared. This is equal to 40,900 minus 441 minus 441. This is minus 324. This is equal to 39,694. Therefore, correct standard deviation is square root of correct summation xi squared divided by n minus correct mean whole square. Where correct sum from I equal to 1 to 97 xi squared is 39,694. So it is equal to square root of 39,694 divided by 97 minus 20 squared. This is equal to square root of 409.216 minus 400. This is equal to square root of 9.216. This is equal to 3.036. Therefore, the correct standard deviation is 3.036. I hope this question is clear to all of you and you are getting my point. So that's all for today's lecture, and thank you very much to all of you. I hope this lesson was helpful to all of you.